Now I want to talk about derivatives. Derivatives are basically how fast a function is changing. Uh, you can take any graph, any function. The derivative will tell the slope of the graph at any specific point. The derivative only goes through the function at one point, making it a tangent to the function. It matches the slope of the function at this point. So, for example, if we have like x squared, we can find out that there's a tangent function right here. This tangent function changes as we move on different points of the graph, getting steeper and steeper, or even more shallow, less of a slope. If we're looking at a specific point, like 1, 1, we know that we can find out that the equation for the graph would be 2x minus 1. Usually, this is the tangent line. Usually, though, in calculus books, you'll see a secant line. So it'll be like from here to the point 1, 1, and it'll only touch at those 2 points. And as we get closer and closer, we bring this up closer and closer to that point over here, so that it's only touching at one point. Like in this instance, the secant line would be y is equal to x, and we bring it closer and closer, and until they're infinitesimally closer, going to 0 distance between them, and that's how you would end up with this tangent line. When we talk about derivatives, there's this, it's called the limit definition of a derivative, so it's f prime. The prime is this symbol right here. It's kind of like an apostrophe. So we have limit as h approaches 0, f of x plus h minus f of x all over h. So it looks scary, but it's really not that bad. H is a constant, and we can start with the constant case, which would just be a vertical line like this. We could say f of x is equal to c. Now we have this f of x plus h, which basically means that whenever we see an x, we add a plus h. But here we don't have that, so we just have f of x plus h is equal to c because there's no x's in this. So when we take the limit as h approaches 0, we get c minus c over h, which is just 0. So the derivative of a constant is, unsurprisingly, 0. There is no change to a constant. Now, what if f of x is equal to cx? If we plug in f of x plus h, now we have c times x plus h, which is cx plus ch. And then using the limit definition of the derivative, And after simplifying this out a little bit, which just is equal to c. So the derivative of the constant is just c. If we say f of x is equal to x squared, now we have f of x plus h, which is x plus h squared, which is x squared plus 2xh plus h squared. Just a simple multiplying it out. So when we take the limit, h approach 0 of this, x squared plus 2xh plus h squared minus x squared all over h, we can cross those out, and we're left with the limit as h approaches 0, 2xh plus h squared divided by h, and we can divide that h out, and we're left with the limit as h approaches 0 of 2x plus h. Because h is going to 0, we could basically cross that out and just say 2x. So the derivative of x squared is 2x. And x cubed is also pretty nasty. I'm not going to cover that, but it's the same process. And there are some rules to derivatives. So there's the product rule. Not the product rule, sorry. That is a little more advanced. But there's the power rule. So if we have x to the n, the derivative would be nx to the n minus 1. So in the case of x squared, this becomes 2x to the 2 minus 1, which is just 1. So just 2x. X cubed would be 3x to the 2 power, or squared. And this works for all powers of x. So x to the 17, 17x to the 16. It works for fractional powers, like if we wanted to do this, the square root of x squared, x cubed, which actually is x to the 3 over 2. And taking the derivative of that would be like that. We can also do 1 over x cubed, which is x to the negative 3. And taking the derivative of that, I guess these could all be like arrows because they're not actually equal to each other. So taking the derivative of x to the negative 3 would be negative 3 x to the negative 2, or negative 3 over x squared. Sorry, I'm tired. Not negative 2, negative 4, because negative 3 minus 1 is negative 4. That's the limit definition of the derivative. That's the power rule. There are some more advanced rules, but like the product rule, which I will cover in another video. It's not that hard, not that complicated. Alright, thanks for watching.